Session this week is going to be given by Jason Karam. It's on Love Lane Curve, a journey from alignment, design to construction. So firstly, can we get some etiquette out of the way, like always? Can we have all mics on mute? Someone's making noise. And for the interactive parts, can we have questions submitted by text in the narrative? Or if you'd like to address Jason, please use the hand up function and Vid will invite you to speak when it's right to do so. Again, questions are filtered by Vid like every other week, and he'll introduce them at the end of the appropriate slide. This is a recorded session again, so please be careful with our language. If we all talk over each other, it'll be carnage, so please stick to the normal etiquette. So last time we learned from Ram Ramburn on project management within the ITT. It's good because it demonstrates how collaborative we work together with the client. It was a very informative presentation again on the trials and tribulations of project management within the ITT. And it demonstrated how the delivery partner and the client work side by side to deliver these heavy projects of the weekend. Also, Jason's presentation is going to be on Love Lane, which was handed back, I'm happy to say, very close to our defect-free delivery goal. So just a reminder, these sessions are all up on YouTube, and this one will be up to close of business today. So anyone with ideas for knowledge sharing, please keep them coming in, or anyone that would like to volunteer, please get in touch. These help to gain exposure for ITT and spread the good word of what we do. So I have a program to cover the next few weeks, so please, any volunteers, please get in touch. Again, there'll be a Kahoot quiz in the middle. I see Pradeep's back, so he's the man to beat in these things. So if we can log on to Kahoot IT, the number will be confirmed later on by Vid. So we've had some good crack on these and they've been very competitive. So this week's is on global knowledge. So Jason's presentation, as I said, is on Love Lane. It's also known as Caso's Curve. It's a 45-meter radius, so it's definitely the tightest one I've ever put in. So Jason has 5 years experience in rail. He was actually a track designer in AECOM before joining ITT as a delivery engineer, and he was involved in the track design for this project. So that's why he's seen it from cradle to grave in the rail sense. He was a rail civil engineer who specialized in upgrading platform structures in his early career. He then joined the P-Way design team to carry out alignment designs and feasibility studies on Manchester Metro Link, London Tram and Network Rail, and HS2 Phase 2B. Not yet on London Underground, but I'm sure it'll come. His focus area is alignment design on trams. So on that, over to you, Jason, and you can do your presentation. Thank you.
Thank you, Damien. So good afternoon, everyone. I'm Jason Kam, and today I would like to deliver a presentation on Love Lane Curve, a journey from alignment design to construction. So I think this is the second week after the core works from Love Lane, so I think it would be a good time to share this experience for you guys, and while still everyone's memory is still fresh. And as the Tram is the new type of project from ITT, so I think it will be beneficial for everyone who is working with Tram. So today our agenda on the first half is talking about some modern Tram feature. Talking about alignment is you cannot exclude the modern Tram feature as well as the Tram alignment design. Second half, I will talk about the Love Lane alignment design process that I was carried out in my previous role. The fourth part is to talk about some of the construction challenge that is related to the alignment design. And eventually I will have a summary to summarize the alignment issue as well as some construction issues for Love Lane. So firstly, we talk about modern tram features. So tram is actually operated by line of sight. In this mode, a tram should be able to stop before a reasonably visible stationary obstruction ahead from the intended speed of operation using the surface brake. And normally tram is also equipped with an emergency brake, but that brake is actually a few times stronger than the surface brake. So normally this is not going to be used. There are several types of tramways normally in UK, and the first one is the integrated on-street tramways, where part of the highway is occupied by the rails, and it may also be used by other vehicles or pedestrians, as you can see from the left picture. The second one is the segregated on-street tramways or tram-only streets, where part of the highway is occupied by the rails and may be crossed by pedestrians but not normally shared with other road users. This particular type of tramways, you will see it away from the town center, which share with half of the highway with another vehicles. The last one is the off-street tramways, where the alignment is the track wholly separated from the highway. So the ballast track in the Love Link, this is an example for Love Link. So talking from the bottom of the track form, there are actually two main rail types. And the first rail type is the groove rail. In UK, normally the operator would like to choose the RI59 and RI60s as their preference. The only difference is actually the flange width, the groove width, which to be catered for the tram to travel in a very tight curves. And their dimension, the width and the height is exactly the same. If you look at the picture, there is actually a flaring thing opposite to the running gauge that is called a keep rail. The keep rail is actually not working as a check rail because it doesn't supposed to be resist lateral force. So the keep rail is actually helps the bitumen not to getting into the groove to avoid the flat contact with the bitumen. Another type of the rail normally used are the flat bottom rail, 80-pound rail, and S49 rail that was chosen from London Tram, and the company used is the 113-pound rails. The choice of the rails is actually dependent on the operator, the tram characteristics, and the traffic loads on those network, and it is pretty entirely up to the network requirements. Going through with the track form, there are several track forms that we commonly seen in tramway. The first one is a direct fix, where you most easily seen on structures like an overbridge, or is just like an raised structure or above and retaining wall. And secondly is the ballast track, is commonly used in is the corridor where it was built from this corridor from the older railway network. The third one is the slab track, which is normally used, is commonly used in street sections. From the picture, you can see the rail is actually encapsulated with like a polymer material, and this type of material helps to reduce the vibrations as well as increase the electrical resistance from the rail. It's sometimes also called the boots of it's like plastic boots. That's what they call in construction. For this particular rail, for the groove rail, this is installed in vertical rather than in 1 in 20 inclination. It is because of the difficulty when you need to incline the rail in a tight curve. So these rails are normally installed in vertical. And the last one is the twin block sleeper, where we can easily see nowadays. The twin block sleeper, you will find it in the segregated sections where the traffic is not above the rail, and the road traffic is not above the rail. And this type of rail is easier to be maintained, and because you can see the rails above. And from this picture here, you just need the final of the concrete of the second stage, and this is done. So this is quite commonly used in the UK newer tram network. Talking about the tram, we cannot exclude the tram fleet, because the fleet is somehow controlling how your alignment can be and what is your capability of the tram, really depending on your alignment. So in I just take London Tram as an example, because London Tram is actually consists of two main types of the tram around the road for the low-floor trams. The first one is the Stella Railroad Band, which is a multi-modular articular cast. You can see it is actually divided up to 5 sections for this tram. And the older fleet, which is the Bombardier CR4000, the configuration of this particular tram is like a Jacob bogie. A Jacob bogie just means that the bogie, two bogies are not mounted on the same wagon, and you can see that the middle bogie is actually mounted on a different part of the body. So this helps to cater some of the articulation issues in the tight curves. Due to the bogie configuration of these types of tram, virtual transition theory is just an approximation and cannot be determined as normally you see in a heavy rail vehicle. And they have shorter wheel space, which is the axle spacing within the bogie. They can travel minimum radius with 25 meters on the slab track, and they have 3 meters overhang and the taper at the front and end. I will talk about the overhang and the taper on the next slide. So when you're taking a tram, the safety of the road user and the pedestrian is pretty critical because they are the interfaces that you will face every day. Starting from the top left picture, this picture is intended to show what is the highway crossing angle. If you see the green arrow, the tram is coming from the right, and the vehicle is traveling at with an angle at a red arrow. At this point, there is a crossing angle formed between the tram and the traffic vehicle, the highways. This vehicle is really important because it could cause hazards to a lot of motorcyclists and cyclists, and their wheels could potentially trapped into the groove. This is not desirable. That's why you can see that from the left, there is an extra cycle lane built at the left, just to avoid the cycle path to pass through the road in a small angle. So it intends to help the cycle path to be actually cross vertically to avoid hazards caused by the groove rails. Looking at the bottom, you can actually see the end throw effects where the arrow is pointing. As the tram is overhanging by about 3 meters, on this particular turnout is around 25 meters radius. So you can see that the end throws is actually very significant in this particular turnout. And this effect is, so the tapered section is helping to reduce the end throw of this tram, because when it cuts the corner on the tram, the end throw or the swap path that we normally call is reduced by a maximum 300 mil on this type of. So when you need to negotiate with highways, and you can take less space, and then they can have a wider pedestrian walkway. From the right-hand side, there is a safety feature mounted on the newer trams on the tram link. That is called underrun protection guard, which is equipped underneath the front of the tram. The intention of this device is to help when there is a collision with a person on the street. The underrun protection guard or the lifeguard just push away the person away from the forefoot and avoid the person to get trapped underneath the tram. So how about for the ballast track? Because the ballast track is lower in the forefoot. So from the bottom picture, you can see that there is actually an underrun protection device. It's a black polymer material. It is actually traveling facing the tram. Its intention is very similar to the run on the highways, where the tram hits a person, is trying to push the person away from the forefoot to avoid crushing the person. You may ask a question, why there is no such device on another track, on the left-hand track? It is because the tram is departing from a platform, which means the driver should be aware of any pedestrian crosser on the track before they starting to depart. So and the departure speed should be quite low on the crossing on another track. So the consideration of this particular device, the length is depending on how the existing speed of the tram traveling, as well as the gradient of the track, because it also affects the deceleration of the tram. Next slide, please. So for tram environment, we come across as quite many of level crossings around the network, and there is a level crossing road profile assessment to be carried out on the level crossing. It was because an accident was happening in level crossing accident in Scotland in 1982. A vehicle was stuck in a 6 foot and causing the collision and derailment of the train, and more than 30 passengers were injured. So an assessment on the road and rail profile against on the 15-meter wheelbase is a good practice. It's not a must on the network rail side, but it's always a good to have to assess the lifting of the track, whether it's affecting the road profile, which could cause dangerous to the long wheelbase vehicle. 70 millimeters, 75 millimeters clearance should be provided for any 15 meters wheelbase vehicle. And this is just a good to have assessment, but sometimes it's not always work, because for 15 meters wheelbase, it is quite long for vehicle, and sometimes this is just depending on how the project engineer or the asset engineer to be decide whether the lifting of it is good enough. So now we are going through the tram alignment design. And before any design, before starting the design, we have to consider various standards and guidance. So every operator in Tram should have the appropriate standard, which is relevant to their network requirement and their fleet requirement. And London Tram has their own track alignment and standard. But sometimes if you are facing with other third parties or interfaces, extra guidance is needed. So the RSP2, which is now called Tramway Principle and Guidance, published by the Light Rail Safety and Standard Board, or you take another reference from the ORR. Some other each design consideration, like when you have the track to be built on ballast track, you would like to have more assurance on your design. That's sometimes we will cross-track with network rail standards to make sure to cover up more if the standard from the operator anything is missed, because sometimes the standard from the operator is not updated as quick as network rail. So network rail is always the is cover up your back. So in tram environment, there are several third parties involvement. Commonly used, which is the civils, the highways, and the traffic. The highways is responsible to build the highway up to standard, and the traffic is responsible for a lot of the road markings as well as the traffic lights control, because Trams has the right of way and a lot of times, so traffic involve this part quite a lot. And the final design element has to match the existing road profile to avoid a bumpy ride for car road users. And sightline is also a very important point, because if you are coming from a junction, the driver has to be aware of any cars or pedestrian coming through to them, so they have the sufficient time to stop the tram. And the location of the PNC, you wouldn't just hurt the pedestrian if you are setting it in a crowded areas. And the swap path is significant, like what I said, because of the passing clearance and the platform positions has to be very tight. So swap path is always a concern when building trams. During the design, you will like to improve the stepping distance on the platform, even though it is not, sometimes it's not required, but it's always good to have this kind of improvement on the stepping distance to try to make it become a standard. And finally, We also consider the speed improvement and the journey time for the particular design. But this is really a recommendation to the operator, and sometimes the operator has their own concerns, such as you have to provide extra training for drivers. That is sometimes not always preferred by the operator, but this is something that is good to have, again, to recommend new speed limit for them, but which is good. You can improve the journey time by 10 seconds, but that is very significant improvement as well. During the design, a lot of the times you are dealing with a lot of speed parameters, and it is no big difference to a lot of the heavy rails. So at the beginning, you have we have to design the horizontal and vertical alignment, insert the transition length or virtual transitions in your alignment, take care with the reverse transition to make it more compliant and improve the safety of the passengers, provide sufficient element length, and provide the correct cant deficiency, rate of change of cant and deficiency, and finally provide a cant gradient to just to improve the ride quality and reduce the maintenance of the railway. And one thing, and there are two things that is unique from Tram. It's quite unique from Tram. Is the horizontal radius and the vertical radius combination. What this means, it is about if you have a tight curve, as tight as 60 or 60 meter radius, or like a 4% of gradient, when these two combinations meet each other, you are actually creating a twist. That you are actually creating a twist in the geometry. This is not a normal twist you will find in the poor construction or poor maintenance. This is actually a design twist that you have to build on, particularly when you pass through a bridge and you have to increase the rate gradient to getting up on an embankment. And this is to be very careful when you have this type of combinations. And secondly is the distance from the tangent point to the platform, as the tram sometimes can enter the platform with a tight radius. The center flow and the end flow could cause the clearance issue at the platform. And don't forget the clearance is about 40 mil from the tram door, which is the standard from the tram, to improve the mobility of the wheelchair users.
Jason, quick question. Do you know what the tightest curve is on the Croydon trams?
I think it is 25, because a lot of the turnouts, the standard turnout is either 25 and 100, usually 25 meters, 50 and 100 meters used in the tram network, because they are pretty standard components and they don't have to procure extra materials for other type of radius. Okay. Yes, and a lot of the times they will have the 25 meter radius turnout in the depot.
Okay, perfect.
So here we talk about, quickly go through the alignment techniques. The software we are using nowadays is the Benny Rail Track or the Open Rail, with the use of microstation in the newer type of software. We carry the regression analysis for the like-for-like renewal, which means we are not changing a lot in the corridor, or we design it from the existing. We have the IP methods, multiple element regression, and this type of methods I will talk about in the next few slides. And in the alignment process, normally we just we design for the vertical alignment, horizontal alignment, and a cant. Once alignment is fixed, and then you fine adjustment your geometry based on your clearance, or is there any particular clearance that the operators want, or changing the minimum length of the element. And finally, you have to auto satisfy all the speed parameters in your design. That is just the baseline. So regression analysis plays a very important role in track design. Regression, the word is you can imagine this word is come from statistics, which means providing a best fit line. So you will, from the existing alignment, you would like to provide a best fit line for your design. So usually on step one, the surveyors will would survey the existing track levels and coordinates, which should be input into a CAD file, the left rail and the right rail, in a particular interval. It depending on the structures you are on. If you are on in a tunnel, you would like to have 5 meters or 2.5 meters survey point. Or if you have a very complicated, like we have an experience that like a direct fixed track or with a double junction, and you would like to survey it in every 1 meter. That is a very small. Normally in network rails, that is 10 meters every rails. And in the second step, the regression point is formed in the forefoot, and this is generated, this just average up the left rail and right rail, and it's formed the center lines, because the center lines is not something that you can survey in the track. Thirdly, once you are happy with the regression point, you can start to design your alignment using the center line. The dashed line is actually indicating the center line you would like to put across this regression point, and you will see that the slew is -3, just indicates that you are at the left of the existing alignment by 3 mil. So from this type of slew, you would arguably saying that this is a tie-in of the alignment. And finally, once you are happy with your center line, you can output your design rail position, the left rail and right rail, and to display your corresponding slew values and display your the geometry, like the radius, length, and the cants, which is normally you see in a lot of the track drawings, general arrangement. Yeah, and there are other curving methods, which is depending on your situations and what obstacle you will face. The intersecting point method, which is the IP method, is the one that to deal with a lot of the simple curves without any transitions, which is usually seen on the vertical alignment, because transition is not required for the vertical curve generally. And you can simply drag the IP from your straight line and put your curve wherever you like. There are other curving methods, like the fixed curve, where you have several fixed points. Like if you have 3 catch pits along that curve and you would like to put that curve just on those points, you can use the fixed curve method. And for the free curve, it is easily to use if you have 2 known straight tracks, and then you can actually put your curve freely by changing up your radius to be smaller or tighter. And finally is the floating curve method, which you come from. Normally if you come from a platform, which is you want to fix the bearings and the position of the straight lines, and then you can just simply extend your straight line and changing your radius to suit your design. And last but not least is the multiple element regression. This is the more advanced technique when you are dealing with a lot of like a compound curves in the love lane or in the reverse curves. The multiple element regression is just help you to fine adjust the alignment, or especially on the compound curve. And eventually, inserting a geometric transition is always required by the operator, which is very good for when you put in cant. So I think this is the end of the alignment method. So now I pass to Vid.
Thank you, Jason. So yeah, it's time for the Kahoot quiz again. Let me just pull it up. So this week it's on flags. So let's see who knows their flags the best. So if you guys log into kahoot.it, it's just loading the pin. The pin is 3135422. So if you guys go on kahoot.it and then just type in the pin, and then yeah, let's test your knowledge. Pretty in there straight away. Galib, nice to see you. Come on, we'll give it a couple of minutes. Try get 10 or so people on. Vid, who's going in as me? Hopefully it's
what's the password?
31354222.
I'm not playing. I want to give everybody else a chance.
Have we swapped names, Ali? Have you gone in as Vid?
No, I'm in as Alistair McLaughlin. I'm the real Alistair McLaughlin.
Rambo. So we've got 12. Maybe I'll give it 10 more seconds. I'm going to start. Hopefully we get one more.
Rambo's shouting at us today.
Okay, let's start.
Yeah.
So yeah, knowledge sharing Tramlink flag quiz, I guess. Which country has this flag? Is it Spain, Belgium, Germany, or Italy?
Easy.
Yeah, easy start.
I should have joined in, actually.
Still time. Yeah, it is Germany, and none of you got it right. So in the lead is Chaz. Nice one, Chaz. Question 2, again, which country has this flag? I think Damon might have an idea.
Easy. Depends which way you got your phone round, though.
What's the other possibility? There you go. We're waiting for one more. Yeah, it is Ireland. 10 of you got that right. Very well played. I do think it gets harder. JW in the lead. So again, which country has this particular flag? It's a tricky one, this. The answers are flying in though, so maybe.
Tramlink's very international. I was expecting it a lot less on flags, really. Do they hang them from the overhead line masts?
The answer to that question was Armenia. Let's see who's in the lead. Chaz knows his flags quite well. Question 4. Which country has this particular flag? Is it Bulgaria, Belarus, Vietnam, or China? It is Vietnam. 7 of you got that right. See if Chaz stood in the lead. Yes. Well played, Chaz. Question 5. Again, which country has this flag? Is it Finland, Sweden, Norway, or Iceland? It is Finland. 8 of you got that right. I feel like I should have chosen harder flags now. Chaz is still in the lead.
Me too.
Question 6. Well, this is quite hard-ish. Which country has this flag? Is it Romania, Poland, Slovakia, or Indonesia?
Not difficult.
It is Poland. 7 of you got that right. So it was considerably harder than the rest. Yeah, Chaz still in the lead. Question 7. Which country, again, has this flag? Yemen, Croatia, Slovakia, or Slovenia? What do you reckon, Ali? What's this?
I really hope you stuck a Sri Lankan flag in there.
I should have done. The answer is Slovenia. Chaz still. Oh, Pradeep's making a little comeback. Question 8. Which country has this flag? I think this one's quite easy. Is it
Come
Brazil?
on.
USA? 13 of you got that right. So yep, Chaz still in the lead. Question 9. Which country has this flag? Is it Russia, Moldova, Australia, or France?
I take it there's no prizes for this.
There never usually is. France it is. Chaz still in the lead. So question 10. This one's hard, surely. Is it Moldova, Kosovo, Macedonia, or Malta?
That is hard. I'm going with Malta.
Yeah, very good. Malta it is. Chaz still leading the way with Pradeep in a close second. So question 11, which country has this flag? Twelve answers in. It is indeed Sweden. 12 of you got that right. Chaz all the way in the lead. The final question, which country has this flag? Is it Canada, Switzerland,
Oh,
UK, or the USA?
This doesn't really say a lot for what you think of the intelligence fit of the people who join the knowledge sharing sessions.
Well, in my defense, it was actually a pre-populated one. So the answer is Canada. Let's look at the podium. In third place, it is JW. Well played. I'm guessing that's John. In second place, Pradeep with his welcome back. And in first place, it's none other than Chaz. Well done, Chaz. I'm going to pass you back to Jason again. Hope you guys enjoyed that. I will pick a harder one next time. Just for you, Ellie.
Right. So now we are getting to the Loveling alignment design process. And so the design of the Loveling was started in March 2009 in ACOM, and the staging design was completed by LU in June 2020. It was a 647 meter ballast track renewal between the Harrington Road station turnout to the Birkbeck stations. It is a like-for-like alignment design, which means no significant change to the corridor is needed. And it also includes a review of the Loveling curve geometry with the corresponding OLE adjustments. We have to provide an adequate lateral restraints of the curve, which is the lateral resistance placed to LRPs. To provide an adjustment switch at the location at the east end, because in existing condition, there was only one adjustment switch. And we have to maintain the existing Birkbeck platform offset, as there's no civils involved in this project. And finally, check rail is not required for the Loveling curve in this particular 46 meter radius, because the tram, according to the tram explanation, is due to the articulation properties of the tram. Just remember they have the bogie, the Jacob bogie configuration to cope with that type of curves. And we have the S49 rails with the NTF 1502 sleeper, which is specified by the tram link. So this is an overview of the proposal alignment to give you a feel of how the site looks like. We're starting from the bottom of the figure. It is the Harrington Road, which is what we mean by the west of the site. And after the turnout, we start through the strict element with a existing adjustment switch. And I've proposed a series of compound curves, which is around 46 to about 60 meter radius with 70 mm of cant. And then we came across to a second, the next strict track, which is the new adjustment switch location. And after that, we are having compound curve with about 450 to 500 meter radius with 65 mm of cant. And after the compound curve, it is supposed to be a straight track, which is designed with 2 kinks this straight track, and we are reaching the Birkbeck platform. At the end of the Birkbeck platform, which is the top right, we have the under bridge straight after the platform. And along the corridor, we have the network rail line is joining more or less the beginning of the whole renewal. And speed limit of the curve is 25 kilometers per hour, and the rest of the line is 70 kilometers per hour. So this is just an overview of the proposed alignment.
Jason, there's a question that's come in from Galib. So he says he understands Loveling alignment is connected to the fleet. So will this mean that the fleet could never change, or the alignment could change in the future with new fleet?
I think usually when they set up the standard, they are setting up according to their requirement. So they actually made some modification when they bought the new tram of the Stadler Railroad band. So, but the alignment standard is basically suitable for the for the future where they have a new trams arrive. So it's like a universal standard within the tram link. But if they need to buy a new trams, which means they have to relook at their standard and see whether any standard needs to be updated, particularly on the gauging, because both fleet behaves quite differently. So they have different systems, which is focused on a particular tramways. So they will review it if they need to buy the tram.
Okay, perfect.
So in the delivery point of view, and this job is divided into 4 weekends, and with week 21, 23, and 24, they are pretty much similar, with about 144 meters renewal, with 27 hours possession from the network rail. Because they are adjacent to the network rail, that is why it's a network rail possession. For week 22, it is week 22 is about the renewal of the Lovelink curve particularly, and it is 79 hours in network rail, and for the tram, which is 96 hours in possession.
So Jason, another question, in terms of kind of staging, do you know
Yep.
why we staged it that way?
I have no concrete answer to that, but I think it's because in those areas, the lift and slough is small, relatively small, and they are on the curve particularly and not on the transitions. So I think in those areas, the main reason is about the lift and slough is relatively small, and as they are actually on a curve or a straight element. So the reason behind the staging is, I think, it's likely to be this.
Okay, thank
Because the London Underground carry out the staging design, so I don't have the solid answer for that one. But
you.
I think, yeah. So when we are doing renewal, we cannot omit the existing condition of the track. What we have found was the poor existing formation at the west deck limit near the Harrington Road. From the picture in the bottom, you see that the formation is actually consists of very slurry and wet ballast, which is full of fines as well. And we have the poor alignment, existing alignment in the Lovelink curve towards the Birkbeck station. From the picture at the right, you can see that the alignment is actually, you cannot consider to be a good alignment. Yeah. And existing adjustment switch near the Harrington Road is on a transition, which is not good for the maintenance side. And we have a non-compliant cant, which is 170 mil on a curve, and a cant gradient of 1 in 200 and Lovelink curve. So cant gradient at 1 in 20 could impose a huge derailment risk for a tram if they are traveling with type of cant gradient. So the scope is also including to review the cant of this particular curve. And finally, we have the poor existing tie-in condition at the back. Because after the Birkbeck, we have the underbridge straight after the Birkbeck. So which means the alignment is usually not that good if you have this type of structure setting up. So here are more pictures of the existing Lovelink curve. And from the left, you can see the existing Lovelink curve was consists of the concrete sleepers with of the timber sleepers. The timber sleepers just helps you to. The timber sleepers actually for the tying in both. If you have a rail on the top to restrain its lateral movement, you can also see that there is actually timber beam things like next to the ballast, which to minimize the movement of the track. But from the right hand side, you can see that the holding down rail is actually in just a short section of the curve. This is not desirable because on Lovelink curve is about more than 100 meters long, and you have the stiffer part inside the curve, which means the stiffness of the track is not to be consistent around the curve, and this could cause the curve to be moved somewhere is more than this area. So I don't know whether this is a good practice or not, but that is why we have a renewal for the Lovelink.
Jason, you know, there's two bits that are circled. And I'm guessing that's the lateral restraint. How does
Yes,
it work?
that is the lateral resistance plate. It's like you can imagine it is like an arm jutting into the ballast. So you have, it's like a plate, and then it can increase the resistance of the track movement, because it's like you having, so it's like having a plate in the ballast. Imagine the ballast is like a water. You have a plate in the water, which means that there are some kind of resistance on the plate. The ballast is moved. So the idea is behind it, I think it's like this.
All right, okay, thank
So
you.
basically, it's to increase the lateral resistance of the track itself. So during the design phase, we have seen several design challenges. And the first thing from the scope is the renewal limit. The original renewal limit is up to the toe of the Harrington Road turnout. This is not ideal because renewing up to the toe, you could potentially change the geometry of the toe and the squareness of the toe, which is not desirable. That's why our final limit is about 10 meters from the toe, which you lift the twist rail for your neck renewal. And have the tight radius with a compound curve on love link. Tight radius in design is not a particular challenge if it is just a simple curve. But in terms of compound curve, everything you move could change the whole lot of setup around the curve. And obviously we have the non-compliant can and can gradient for the love link curve. And we have the catch pitch adjacent to the love link curve. And from the picture, you can see that we have the existing fence and fence posts next to the corridor of the tram. But unfortunately, this is not, the clearance is not known, and they are not, and the network rail, 6-foot rail, is not surveyed due to the blockade issues. The tram profile is also not available for the Clearroute 2, and Clearroute 2 is just a software to check the clearance of your vehicle to your structures, and the profile is not available, which means you cannot do anything worse than the existing to make the clearance worse. And finally, the effectiveness of the lateral resistance plate in the curve is unknown, because at the moment this is installed on every sleeper with one lateral resistance plate, and you may argue that why it is not one plate per 2 sleeper, 1 plate per 3 sleepers, or 2 plates per 1 sleeper. So that is why we have just installed 1 plate per sleeper and hoping that it could provide a maximum resistance on the curve to minimize the movement. And this picture also is a good indication to show you the alignment beyond the platform. So the darker rail at the far end is actually the underbridge. The alignment has to cope with the underbridge, which means the alignment tie-in is not going to be very good. So when we talk about derogation means that if we are designing something that is departure from the standard, so it's departure from the exceptional limit in the standard. In this particular job, we have several short elements along the love link curve, which needs to be at 25 meters, but we have only 14 meters. We have the existing geometry with 46.5 meters. From the standard, it is actually 150 meters for a ballast track, and we have talked to Tram that is actually the love link curve should actually to be built on a slab track and not a ballast track. And geometric transition should be provided wherever possible. And finally, we have the reduced acceleration with particularly at near the tram stop areas. And this derogation has to be submitted to the London Tram for the asset manager to be reviewed and recorded. And once they have approved it, and then which means our design can pass through to the AFC and approved for construction. So here is a bit of the evaluation on design after it is all constructed. And there are always good and bad things that you can be improved. And a good side for this alignment is finally we have the compliant geometry. It's designed from 170 mil and down to 70 mil to keep the can gradient to be in compliant. And we have the platform offsets to be maintained without civil works, and that is quite good because if the platform condition is not good enough, we cannot maintain the platform offset without the civil works. And finally, we have the use of the eco-track sleepers as a lateral restraint to maintain the platform offsets. So it actually restricts moving towards from the platform. But this is not a general practice in network rail, because in network rail, the vehicles are more heavier. If you imagine it's traveling in a curve, the centrifugal force putting on the platform wall is huge. This is why it's only, as far as I've seen, it's only happened in tram network. And there's also several improvements for this design. And for example, is the tie-in at the platform is not ideal, and it should be within the 100 meter of the renewal, as you have seen in the picture. The adjustment switch is designed on a hot curve. This is due to the existing topo area is for this particular curve, so we cannot design out of this. And during the construction, we have the near miss at the catch pit ring at the start of the love lane curve. I'll talk the catch pit later on. And the network rail is not surveyed due to the blockade issues. If the network rails we can be surveyed, which means that we can have more assurance on our clearances and to provide a better alignment. And finally, is the multiple kinks are designed at the rest of the back platform, like in the figure below. In the figure below, it is like a 500 meter radius traveling from the left, and you have the straight track from the back. Ideally, it's just a straight track and it transitions to a curve. But in this case, due to the unknown clearances of the network rail, we have to stool away from the network rail. That's why we create quite a bit of offset, and our transitions cannot be putting in. So that's why several kinks are actually designed for this job, and that is also approved by London Tram. But this is not ideal, definitely not an ideal case, especially when you're entering a platform. So finally, I'll go through some of the construction challenge that is related to the alignment design. And from this picture, we can see that the deck width is actually quite narrow, and we have to achieve 3.6 meters from London Tram. And in the left, you can see that there's actually a fence, which is a network rail asset. And when you are doing the excavation, you cannot actually undermine the foundation near the fence. At the right-hand side, we have the cable trough actually on the edge, and that is our full width of deck. And we changing the fence and rerouting the cable trough, not our scope. So we have to accept that as a derogation, this is non-compliant deck width. Talking about the tight clearance, this picture we have seen before is I would say is a near miss in the alignment design, because you can see the catch pit ring, which has an edge with the white mark on it, but about several centimeters below, you can see the another catch pit ring, which is kind of blocking up the sleeper installation, because in original topo survey, you didn't realize there is a ring underneath the top of the catch pit. So you have to install the eco-track sleeper. You see the base plate is very close to the edge of the sleeper. That is not ideal, because the base plate could impose a lot of the stress around the sleeper corner. That is not very good for the sleeper. But I think that is one of the near miss during the design stage. From the right-hand side, we can see that there's an adjustment switch at the east end, and this adjustment switch is very close to the catch pit at the right. And during the installation of this catch pit, I think the catch pit is breaking up apart a little bit. But fortunately, before the handback, we have reconstruct the catch pit again. But I think this is a missed opportunity again, because if the adjustment switch is moved by, say, 2 meters away, and then all the clearance issue would be solved. So I think this is the area we can improve. And the first thing is about the unknown temper capabilities, because during the design stage in the early days last years, and the engagement of we have not a lot of engagement with the contractor, and we don't know what type of temper and what type of temper could be used for this particular radius. And in the delivery stage, I realized that the temper can only temp the radius with larger than 50 meters, but the design radius is actually 46.5 with a 40-meter long. So routes has to be manually slewed and lifted by the surveyors and the gangs to achieve the class 1 tolerance, which means additional time have to be spent on laying sleepers and rail. And I asked the question, so can the radius to be designed larger than 50-meter radius just to cope with the temper capabilities? But I think the answer to this is maybe it's likely to be no, because changing 1 meter radius in this particular sharp radius will cause a dramatic change in the slew values. So so I think changing to 50 meters radius is quite a bit far away from the 46. So I think, but that is always good to try back in the office. But I think once you know the temper capability, it's too late to do any design changes. And finally, the quality team has received a lot of the close call regarding the survey pack issues. So on site, we have seen a lot of the member of staff hanging their clothes on the survey pack, and I've even seen it also acts as a geotextile stopper along the embankment. And if you look at the figure in the middle, if a survey pack has been moved, it could be moved up to 50 millimeters at the top, which means during the setting out, your design track may be moved by 15 millimeters, which is a false indication from your setting out. So in the near future, I think we should emphasize the importance of the packs and how it's actually related to the quality of the alignment of the track. But it brings up another questions is, does this mean that a clothes hanger are needed for the site for members? That is a future discussion regarding on this topic. Yeah. And these pictures are the final outcome. From the left, you can see that is the back platform. And in the middle picture, you can actually see the yellow bits in the forefoot. They are the lateral resistance plates installed on every sleeper to avoid the movement of the track. And the next two pictures are just the finished product of the Loveling curve. And in summary, doing the alignment design is an iterative process, and there is no right or wrong answer for alignment unless you are getting very wrong. There are a lot of good practices, but this is not strict standard for alignment. And the second thing is the non-compliant alignment does not mean that it's a bad alignment. This is because if you have to deal with several interfaces, you are not going to try to persuade other interfaces to change their catch pit, change their platform offset, rebuild their corridor, just to cope with your alignment design to be compliant. So this is not something we want. That's why a non-compliant alignment is not a bad alignment. And the early engagement with the contractor is required, because probably we will know the capability of the tempers, and we will know how the staging be designed in the first stage, which we can finish the AFC of the design early on. And finally, the passenger and the road user safety and comfort is a very important, particular in tram environment. So never forget about passengers and road users. And finally, as a consultant or as a contractor, our ultimate goal is to reduce the maintenance of the access and increase service life, and to build a better railway. So this is the end of my presentation, and thank you for your time, and also thank you for anyone who has been involved in the delivery process. And as a designer for this track, I'm pretty happy with the outcome. And also thanks with the defect-free engineers, which is newly deployed in on site because we have been closed out a lot of the doubts and with the minimal defects that we can find on the site. So, any questions?
Jason, there is a question from Pradeep. How was it received by Trams? Did we exceed their expectations?
So in terms of if there are two aspects in terms of alignment design, I think it was quite a good, not I can't say good. So say that again. Is probably is good or okay, because we have a lot of negotiation with Tram whether how is the curve to be worked out, and we have actually steering quite a bit on the Tram link to make sure they have the decision to be made. So I think in the alignment side is quite good. I think in the construction side, this job, as far as I've seen from what I heard, the outcome is quite good, and we have a lot of the doubts to be closed out, and a lot of there's not much defects on this type of project. So I think it is quite successful in terms of alignment and the construction side.
Perfect. There's another question that's come in. Did we ever consider using mechanical or mechanized slewing to achieve the final alignment? Guys, yeah.
Can I just come back just before you get onto that question?
Sorry,
Can I just come back to just give another view on how it's been received by Tramlink? I think was Pradeep's question. From a director level, we've seen a huge amount of praise on the ITT for the work that we've carried out at Tramlink. They've used words like delighted with the job, etc., which from a client side of things, you don't really get that often. And for them to be saying that, also they've referenced this standing start because we've just come back from this COVID break, etc., and not having any work. And they were really impressed with what they saw, both in the way that we carried the works out and the works that we've carried out. So at director level, there has been nothing but praise for us as a team for doing that, which makes me very happy, and it should make everybody else very happy around this call too.
Yeah, for sure. Perfect. Thank you, Ali. Jason, the next question is from Steve Everest. His question is, did we ever consider using mechanical or mechanized slewing to achieve the final alignment, like a Geismar lift slew trolley, to avoid manual lifting of the heavy duff jackets or jacks?
To this question, because I'm quite new, I'm not sure how this type of lift to be used, but I think part of the new tool that we can use in the future, if that could be avoid heavy stuff of the track, because I know that those jacks are heavy and they're just pretty heavy. I think you get your point that it could be implement in the future.
Okay.
But if we have the temper to pass through in those positions, we do not require this type of tool anymore. But providing that we know the temper capabilities before.
Yeah, makes sense. Okay. Something we can take away as well. Damien, you raised your hand.
Yeah, Vince, just to touch on what Steve Evers asked there, we did look at the Geismar slewing trolleys for a previous job. Dan and Roos done a bit of work with it. I think it's not approved is the problem,
Right.
but it is something that we are looking at and we are actively chasing, if you like.
Perfect. I don't think there's any more questions. So Damien, if you'd like to wrap up. Thank you, Jason, for the presentation. It was very informative.
So thank you, Jason. Yeah, that was very informative. He's quite young, but he's a very knowledgeable guy. Demonstrates the delivery certainty that we offer at ITT, which is a good thing. That we're going outside of our usual comfort zone. So these knowledge sharing sessions are hopefully going to lead to continuous improvements through feedback, promoting the best practice and promoting success at ITT, because we're very good at what we do. And it does capture a lot of the absolute unique ITT expertise that we have. This presentation, again, has demonstrated how collaborative we work, you know, across both TFL and BB. That was a unique challenge. Certainly, a 46-meter radius curve. It doesn't look right, especially with that check rail. But if that's the way, if that's how it's designed, that's okay, I'm sure. So I'm looking forward to the next session. The next session is going to be done by one of our busiest colleagues, Amar Rashid. And I think some of us will actually get to appreciate what he actually does for a living. So thank you for your continued support and helping spread the word. And this is a good platform, again, for touching base, especially when we're all working remotely. And it's good to touch base with everyone on a regular basis. So keep the suggestions coming in. And I'd like a couple of volunteers, please. I'd love some TDU guys to do it. I see Phil Gallagher's on, so it'd be good if somebody could volunteer from there. So have a think, keep the suggestions coming in. Thank you, and salam for now.